Right, so I'm going to give you some mathematical facts that you might find very helpful in proof questions in particular. Now, the first two are quite obvious. You'll know these from GCSE, right? So if n is a natural number, so that just means 1, 2, 3, 4, 5, 6, 7, 8, so on and so on, the positive whole numbers, then 2n must be even, 2n minus 1 must be odd. Now, the next fact to be aware of is that the product of two evens, so again, the word product just means times, right? So times two even numbers together, you get an even number. Let's just look at why this is. So let's just pick two even numbers, so 2n and 2m, where n and m are both natural numbers. Obviously, that gives you 4nm. And obviously, this is 4 times an integer or a natural number because n and m are both natural numbers. So n times m must be a natural number. So in other words, it's 2 times that integer. So it's obviously going to be even. Now, next, product of two odds is odd. So again, we'll take numbers n and m that are natural numbers. We'll do 2n minus 1 times 2m minus 1. We'll expand the brackets and we'll get something like this. And the trick here is to notice that we've got an even number here, an even number here, an even number here. We can actually factorize out 2 from these first three terms. So we've got some kind of integer here, some kind of natural number, whole number, and we're going to times it by 2. Now, when we times any number by 2, it must be in the 2 times table as well, any whole number by 2. So any natural whole number by 2 times by 2 is in the 2 times tables. So this is even there, but then you're going to add 1 to it. So obviously that makes us an odd number. So we have an even number plus 1. Again, pick your favourite even number, add 1 to it. It's always going to be odd, isn't it? So that's odd. Now, another nice result to know of is that the product of two consecutive integers is always even. In fact, to be really, really precise, I'm actually just going to change that word integer into natural numbers because technically we're speaking about positive whole numbers and positive whole numbers are called natural numbers. So again, we'll let n be a natural number. So what's the next consecutive number after n on the number line? It's going to be n plus 1. So obviously you've got a number line like this, right? So the product of two consecutive natural numbers is going to be n times n plus 1, of course. Now, how do I know that this product, this value here, is even? Now, you may be tempted to just take this and expand the brackets, okay? That's a very natural thing to want to do, of course, so just expand the brackets. Now, the question becomes, how on earth do you show that there is even? Well, actually, you can't really do much at this stage here. So you would get this here, and then you could do a kind of case-by-case analysis where you say, okay, let's pretend that n is even. So plug in this even number, plug it into the n values there, and then plug in the odd numbers, plug it into there and there, expand all the brackets, simplify it, see what you get, and hopefully both cases give you an even number. But there's actually an easier way to explain how this thing is even. I want you to draw a random number line, pick some random consecutive numbers like this here, and just go ahead and circle the consecutive pairs. So you've got 10 and 11 in one pair, 11 and 12 in another pair, 12 and 13 in another pair, 13, 14, right? So you've got all these pairs of consecutive integers. Now notice if we look at each of these pairs, notice that each pair contains an even number and an odd number, right? 10 is even, 11 is odd. 11 is odd, 12 is even. 12 is even, 13 is odd. So each pair contains one even, one odd, which makes sense, right? Because if you pick two numbers in a row, obviously one's going to be even and one's going to be odd. You're literally doing an even number times an odd number. And when you do an even times an odd, expand the brackets, you're going to end up with this. And then again, you can factorize out the 2. And again, 2 times any whole number is even. So this must be even. So what you can say in an exam answer, for certain, you know that one of these numbers must be even, but the other one must be odd, right? And when you do even times odd, you get an even, right? So therefore, you know that n times n plus 1 is even. So the product of two consecutive integers is going to be even. And again, continuing with this theme of consecutive integers, well, the product of 3 consecutive numbers is actually a multiple of 6. Again, it's a very similar reason to what we just talked about. So again, you let n be a natural number, right? The product of these 3 consecutive numbers is going to be n times n plus 1 times n plus 2. So what do we know about these 3 consecutive numbers? Well, again, let's draw like a random number line and let's just pick any triplet of consecutive numbers. Let's go with these ones here, right? So 13, 14, 15. What do I know about those 3 numbers? Well, one of them must be a multiple of 3, right? Obviously, right? If you pick any 3 random numbers in a row, again, let's pick this triplet here, right? 9's multiple of 3. I could pick this triplet here. 12's multiple of 3. One of these numbers is definitely going to be a multiple of 3, right? When you pick any 3 consecutive numbers. So one of these numbers must be a multiple of 3. So again, either n or n plus 1 or n plus 2 is a multiple of 3. Now, how can we now conclude that therefore this product must be a multiple of 6? Well, again, what do you notice about all these triplets, right? they contain even numbers, obviously, right? Look at this triplet here, right, contains 10 even number. Look at this triplet, contains 12 even number, right? This one contains 14. Now, if we pick a triplet like this triplet here, do we see that this triplet has 2 even numbers, 14 and 16? So I can guarantee you, regardless of which triplet you pick, there is going to be at least one even number, okay? So again, I know that either n or n plus 1 or n plus 2 is even, or maybe 2 of them are even, right? Doesn't really matter too much. So if at least one of these numbers is even, well, what do you know? An even number times by any number you like, right? Pick any even number, times it by any whole number you like. You're always going to get an even number, right? So you know that this must be even, because again, at least one of these numbers is even, right? Even times anything is even. So we've got this thing here, it's even, so it's in the 2 times tables, in other words. It's also in the 3 times tables. So a number that is in the 2 times tables and the 3 times tables, guess which times tables it's also in? It must be in the 6 times tables. Therefore, n times n plus 1 times n plus 2 is a multiple of 2 times 3 because it's even, and a multiple of 3, so it's a multiple of 6. Now, another thing that I thought I'd mention, don't forget your difference of 2 squares from GCSE maths. So again, that is when you have a difference of 2 square numbers. So x squared take away y squared is x plus y, x minus y. Don't forget that. So knowing the difference of 2 squares really does save your backside with a question like this here, where it says prove that this big number squared take away this big number squared is a multiple of this horrible number here. Well, if you know your difference of 2 squares, you'll very easily see that you can factorize this number in the question. So use your difference of 2 squares and then do this number plus this number. Sorry, my bad, I made an error there. Sorry, that should be a 6 there, 6 there. So again, you add those 2 numbers together, and then in the next brackets, you take them away, work out what numbers you get, and then you work out these numbers on the calculator. You get 98132 times by 96738. And guess what the question was? Show that it's a multiple of 96738. Well, guess what? It clearly is. Now, one more thing that is quite cool to know would be the difference of 2 cubes. I don't think I've seen an exam question where they demand that you use this, but I have seen a question where you kind of can use this form here. So I'll just go for it. So the difference of 2 cubes is actually this result here, x minus y, and then x squared plus xy plus y squared. So if you were asked to prove that 9999 cubed take away 777 cubed is a multiple of 9222, then again, you could just use this result here. So you could factorize it like this. So then you get 9222, which is this there, and then plus all this stuff here. So therefore, obviously, this number goes into this number. So therefore, it's a multiple of 9222.